Hello, hello. One sec. Hello, hello. Who do we? Hello, young. Good after. Here we go. Now we're talking. All right. Awesome. Hello. I'll say yes. Good afternoon, Sydney. Good afternoon, Samantha. Hello, Karen. Good afternoon, Yaneli. And thank you for having the avatar. Good afternoon, Genesis. Good afternoon, Kaya. Did I just lose? Good afternoon, Ariana. Good afternoon. Oh, and there's Gabriella. She's doing the thing. All right, that's awesome. That's a million points and a million. Awesome. Thank you. Awesome. Okay, wait. Ariana. Sonam, good afternoon. Good afternoon, Roger. Hello, Erica. And more people coming. Okay. 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 All right. I think we're all here. Good to see. Oh, no more. Good to see everybody. Well, really, let's, it's good to see Gabriella. And Andre. Okay. Awesome. Now we got, see, we're representing. Good morning. Good morning. Good afternoon. Good afternoon. Oh, there's more people. Okay. Okay. Um, and hey, Duran, awesome, awesome. All right, so we're all here. Those of us who are here are here. Let's get this party started. So now again, the ratio of physics to other stuff hopefully gets higher each class. We do more and more. Who? Someone else just. So I think I'm ready to just dive into homework 2 now. But again, that's because I think I'm ready. If there's any question at all, like what the agenda for today is for me to go over homework 2, and then we'll get to homework 3, et cetera, et cetera. Uh, that's the agenda. But if there's any question at all lingering from the end of homework 1 or from procedures in general, or like where anything like that, please, this is a good time to ask it. Like I'm going to turn the page and start talking about homework 2. But if there are, but please, if there's any questions at all, feel free to ask. Okay, we're good. So we're good. All right, so it's about homework 2 now. Hang on, I did this wrong again. Yes. Okay, so it's about homework 2. Um, the main takeaways there's no new equation. We're not going to learn any new equation today. We're really starting today to see the importance and power of this equation of average velocity equals displacement over time. And a big takeaway for today also is going to be something I've written before, like there's a difference between a triple equal sign and a double equal sign. There's a difference between a definition and a discovery. There's a difference between a step 3 GDP and a step 4 PAW. Like there's a difference between what we know always to be true versus what we find out to be true in certain circumstances. And we really want to be careful about that distinction in physics. Um, and we really want to, in general, understand that the average velocity is defined to be how the displacement per the time of some space-time interval. There's other things that sometimes it could also turn out to be, but what it always reliably is, what average velocity always is displacement per time. And what average speed always is distance per time. So when you're starting a problem in physics, hard or easy, you want to start with things that are always true in the step 3 GDP. So that's what we're going to see today. Yeah. Okay. So the first thing is, so this is homework 2, part 1, the warm-ups. What I've done here, please note, I've just scrawled out the answers because they're warm-up exercises. I think a lot of people, I saw your homeworks. I think a lot of people were totally fine with them, but there might be questions. So just so you can check like your work or whatever, these are the final answers for the warm-up exercises. You could get these answers and not get all the points if you didn't show all the steps. I'm not showing all the steps here. Anyway, these are the answers if you want to ask any questions or check. But what I really want to, but so you could check and ask questions. But other than that, I'm going to talk in more length about the next two problems on the next page. Also, look, one more plug, because this came up in the last section too. Again, please know, we're still at a stage in the year now where your job is to submit a first draft to a homework by the time it's due. As long as you've done that, as long as you've and right now in the stage of year two, where probably there's exception, whatever, you submit a first draft to a homework assignment when it's due. As long as you do that, you will initially get a ton of points. As we proceed through the semester, you'll see that sometimes you'll get that ton of points, like not all the points, but you'll get a ton of points right away, just to sort of acknowledge, I see that you handed in your homework on time. You've made a first draft on time. So you get a ton of points. And now you have as long as you need to keep doing revisions and fix things according to what we do in class to get the rest of the points, right? I mean, I think this is clear to most people, and most people have been already taking advantage of this, which is good. But I'm here to, again, make a couple of things clear. Once you do that initial burst, that initial first draft, and you get an initial burst of points, that's a signal that you're in the correct bucket. You're good. We're good. And now you're just going to work to get the rest of the points, whatever you need to do to get them. I'm saying all that to say, as we get deeper and deeper into the work, sometimes I'll give you that initial burst of points and I won't even give you feedback if I'm running out of time and I want to make sure that you see that I see your homework and stuff like that. Sometimes you won't even get extensive feedback on the first shot. You're just getting a bunch of points to say, we're on the same page. Now watch what goes on in class. And either you're going to see what you need to do to fix the rest of it, or you already know, like you already only turned in like 3/4 of it. And you already know you still owe me whatever. Sometimes on the first draft, I'm not even going to give you a bunch of feedback. It's going to be sort of clear in class, and you'll just go back and do revisions until you get all the rest of the points. So please, in other words, please forgive me, but also understand, as long as you get a big bunch of points right away, it means probably we both know that there's still things that can be fixed. I trust you to fix them. And you'll figure them out in class. So two implications of that. One, if by the end of class, if we've talked through it all and all the stuff, and then you look back and you're like, no, honestly, like that was a good class and everything. Like, thank you, Yaverbaum. But I'm looking at this and I actually think that I did everything. I think I did all the steps on every single problem. I actually think I nailed it. And I think class just confirmed that. So you're like, so I don't even know why I didn't even get all the points. Or like, what am I supposed to do to get the rest of the points? Sometimes that might even happen because I'm moving so fast and I don't want to fall behind either. So in that case, if you've gone through all class and you've seen now all the answers and you're pretty confident your first draft was great, just resubmit the same thing. Don't kill yourself. Don't stress it. Don't get angry at yourself or me, whatever. Just put the same draft again and just even write a note saying like, I actually think I nailed this the first time. And that's fine. And that's probably true. And then I'll just give you all the rest of the points. And if you put that note, then I'll also register in my mind like, oh, that's my bad, not theirs. And I'll understand that you're a rocking student. I'm serious. Like, so sometimes that will happen. Sometimes I'm just giving you a little space to do another revision and maybe it doesn't even turn out that you need to. So, but just put the new document up, leave the old document behind, put your new copy of the same document up just so I see both and just write a note like, I actually didn't need to revise anything. Can I have the rest of the points, please? And you'll get them. Okay. The flips, hopefully that's clear. The flip side of that, so I'm still saying, in other words, any of you who's still looking for more points on anything that you turned in on time, you still can get them. There's no deadline yet on any of these kind of revisions. Flip side, we'll get to the point soon where in order to get all the rest of the points, you would have at least had to turn in the first draft on time. Like we're still being a little flexible now because there's confusion sometimes at the beginning of the year, but like maybe by the third homework or the fourth homework, like in order to get all the points, you first have to make that draft deadline, And that's why I give this initial burst right away so I can tell and you can tell. I think you understand what I'm saying. If there's any confusion, let me know. I'm just bottom line saying you could still keep revising and uploading as we proceed. My feedback will be coming sort of more and more in the context of the class, or more and more quick, just like step 2. You don't have step 2, and I'm expecting that you know what that means, et cetera, et cetera. Okay. But I think if there's no question, I'm just looking at the chat. All right. If that's cool. So yeah, so a lot of you did average speed and you got very little feedback and you got like 24 points or something like that. So just find out today if you see what it is that you need to fix. And if you don't, just resubmit the same thing and you'll get 30 points. That's what I'm trying to say. Okay, so moving to the problem, hill figure. Okay. So this is hill figure now. Problem 2, a little bit more involved. There's something I want to correct in my diagram. Oh yeah. Okay. So step 1, diagram and fact pattern for problem 2. Here's my sort of primitive, sort of bad diagram. Something's going wrong with my stylus and tablet today. I apologize. So everything's a little bit wonky, but my diagram, there's not much going on in the diagram except for one key point. Even that one key point is not clear. The one thing in the diagram is that he's going up a hill, and the distance up the hill I'm labeling in the diagram as X up. I'm sure you could do a better job with your diagram than this, and then he's coming down the hill and I'm labeling that X down. Subtle point, but remember what I said the other day, like the main purpose of a diagram ultimately, especially as things get complicated, the main purpose is to use labels in the diagram as ways of defining constants and variables, i.e. letters, that you're going to be using throughout the mathematical solution of the problem. So the secret real point of a diagram really is to use labels to establish definitions or define the terms that you're going to use. So I'm trying to establish right here that I'm going to call the distance up the hill X up, and I'm going to call the distance down the hill X down. And if my diagram were better, it might be more evident in the diagram that really right off the bat, I'm noticing I don't know what that is. Like, and that's going to bother a lot of us. I don't know the length X up. I don't know how many miles, but I should recognize before I go, as much of an unknown as it seems like, what I do know is that X up equals X down, right? Like, and this is like a perspective thing. Like, it seems right from the beginning of this problem that there's a lot you don't know. Like, you don't know the size of the hill, so you don't know how much time it takes to go up the hill or down the hill. It seems like a lot, but it's a lot because it's really only one thing that's being phrased a bunch of different ways. It's important for me to recognize right from the start that the reason it feels like I don't know a lot about this problem is that actually there's one thing I don't know, the distance up the hill. And everything else that I don't know is just another version of that, right? Distance down the hill is the same as the distance up the hill. The time up the hill, I don't know, but I would know it if I knew the distance up the hill, et cetera, right? So my diagram is sort of trying to make that clear, but it's totally not. And then also in the diagram, I'm writing that the average speed, that the average speed up the hill is 40 miles per hour and the average speed down the hill is 60 miles an hour. Quick note on this now. Quick note on this, because somebody in this class asked a really good question. Yeah, Monday. I'll think in a minute. I won't. I can't remember if it was in direct chat or in public chat, so I won't say the name at the moment. But I know who you are. So somebody asked about average speed versus average velocity, which of course we're making a big deal right now about the distinct. Like average speed is technically the scalar quantity. Average velocity is the vector quantity. Average velocity cares about direction. Average speed does not. Technically speaking, you could say that average speed is the size or the magnitude of the average velocity vector, if you've ever heard that kind of language before. Um, Now, and the thing that was good about a person's question 2 days ago is, in a way, we're making a really big deal about this distinction. Like, it's like one of the only things we're learning right now is velocity versus speed, displacement versus distance. But that person who asked the question also noticed that I seem to be very casual in my language sometimes about those two terms. What I want to make clear is that from here on in, more and more we're going to be focused on velocity. More and more we're going to be focused on all vector quantities. More and more we're going to be focused on quantities that deal with direction. And more, therefore, we're going to use the symbols and the symbolic expressions for those quantities. And more we're using equations in this class. When we talk about the original notions that when we talk about the original ideas in our head that velocity and displacement are based on, I still tend to use the English words. Like these answers here were, for the first question, was asking average speed. So I wrote out the answers in English, but I still wrote them out as complete thoughts, right? I wrote like average speed equals 30 miles per hour as a complete thought. What do I mean by a complete thought? I mean it has a subject and a predicate, or it has a noun and a verb. I want you to see that in the end of the day, we're moving more and more to equations, and we're moving more and more into precise vector quantities. What I kind of want everybody to see as we move towards equations is that it's just that. It's a move towards equations. I want you to see that in English, in Chinese, in Hebrew, in whatever our native language is, we think in complete thoughts. We express ourselves in complete thoughts that have nouns and verbs. And then when we get into things that look like math or look like physics, they are just abbreviated symbols for what continue to be complete thoughts. Like even when things start looking like shorthand or like math or like abstract or like looking like something else, we're still thinking and communicating in complete thoughts. In math, everything in math is a complete thought. It's just a complete thought is always an equation. An equation is a thought that has a noun and a verb in it, or a bunch of nouns and a verb in it. It's just that in math, the verb is always equals or is equal to. Like seriously. So what I'm trying to say, when right here I'm scratching out things that look like math English, they look like half English, half math. I'm trying to show you that this is a steady evolution. An equation is just a sentence where the verb is equals. So when we're in this like realm here where the ideas hopefully still kind of make sense and are like naturally occurring ideas to us, I'm writing things like average speed equals 30 miles an hour. When we get into this next problem, as the person yesterday asked, in the next problem, what they actually still ask for in the end, they ask for something about average speed. They're asking if the hill goes up at a certain average speed of 40 miles an hour and comes down at an average speed of 60 miles an hour, what's the average speed for the whole thing? So in the end, I'm still looking for average speed. I'm still going to express my answer to that in like an Englishy kind of equation. But I'm getting to the point already where I'm starting to see that equations and symbols are just a faster, more efficient way to capture my thoughts. So I want to analyze this problem with equations and math, right? So I'm going to use average velocity and stuff like that to analyze the problem. And all my analysis should still make sense. It's not like math is not something over here that's just like a different way of thinking or something like that. It's just an extension and an abbreviation of thoughts that should always still make sense in my native language. So I'm going to start using the symbols here and stuff and analyzing this problem in terms of velocities. But as the person yesterday who asked, and again, if it was public, I'm happy to use your name. So let me know. Like, it was a really good question. And I'll move on in a second. But like, I'm going, and I know my handwriting here is illegible too, but I'm going to start using that business of V bar equals X minus X naught over T. Strictly speaking, that is about velocity. It's not about speed. So therefore, to be really careful and to honor that person's question, like I'm going to say here, what's given? What's given is that the average speed on the way up is 40 miles an hour. That means the absolute value of the average velocity on the way up is 40 miles an hour, right? Like apparently it doesn't even matter to this problem that up could be called positive and down could be called negative. What matters to this problem is that the rate that I'm going up is 40. So I'm literally saying like absolute value or magnitude of velocity average on the way up is 40. Then I'm saying absolute value of the average velocity on the way down is 60. Those are my given facts. And what I'm being asked for, so that's my step, that's all part of my fact pattern of step one. Then step two, what is the problem asking? The problem is asking, it's asking what's my average speed. So it's asking what's the absolute value of the average velocity for the whole round trip. Like it's not asking for a negative sign. It's not asking on average which direction were you going. It just wants to know on average how fast were you going. So I'm going to solve for the absolute value of the average velocity of the whole thing. I'm doing absolute value because that means speed, but I'm using the velocity symbol because it's actually easier to work with now that I can get somewhat mathematical with this. I mean, I know there was a very long answer. In a way, that was all a long thing to one person in a way. Again, I'm just trying to say, I think it was a great question. Like you could tell, like it sort of stopped me in my tracks a little bit in a good way. But I'm also saying to everybody, as we proceed into things that look more and more mathematical, for some of you, that'll be a big relief. Like some of you are like, can we just get to the math already? Geez, like that's what I'm good at, or that's what I like, or whatever. So, but some of you are going to be, the more mathematical it gets, the more you're going to be lost, maybe, or feel lost. And some of you are going to think as things get more mathematical, you might think, oh, so now we're just like doing like math wizardry. It's just like black magic now. Like we're done with trying to make sense out of this. We're just turning the crank. I'm trying to stress to you, no, 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 no. Math is just abbreviating thoughts that should all still always make sense. Physics in the end is physics. It will take longer to think about as we proceed, maybe, but it should still always be coming back to things that actually make sense. That's the belief of physics. It's not just made up. In other words, bottom line, I'll move on, I swear. Bottom line, this is why I always use the word equations. I never say formula because I don't believe in formulas. When people think formulas, they think of like just some weird statement that someone just made up or discovered in some genius lab somewhere, and then you're all supposed to memorize and just accept on faith and move on. I'm saying no, 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 no. There's no formulas. There's no formulas. There's equations which are just thoughts about how one thing is equal to another. And right now, the only equation thought we have is we're just defining one thing to be another. So I'm urging you to think, no matter how mathy it gets, still think of it as thoughts that make sense in English or Chinese or Spanish or whatever, like for real. Okay, so it was a great question. I'm going to move. I'm sorry. Okay, so I go to step 3, GDP. Oh, yeah, I know my diagram is terrible. Wait, is that so? Okay, am I gonna open up a portal for sarcasm? Wow, Alfred, yes, it was a terrible diagram. I'm sorry. I'm partly blaming it on my stylist, but like, no, it's really me. Okay, but thank you for your support. All right, so, but that was step 1 and step 2. Now, step 3 is and if that is like, if you're actually asking me to explain something in diagram, but feel free, I will. But okay, so step 3 now. Step 3, GDP, general definitions or principles. Often it's a triple equal sign. It's got to be something that is true even before the problem even started, right? Something that's true, not something that we make up in the middle of the problem, something that's true going into the problem. Now, there's only one thing really in this class that's true, or certainly only one thing so far that could be expressed as an equation, and that is average velocity equals displacement per time. That's my GDP. Now, you don't get all the points unless you wrote this down. I know I'm being like a little bit of a jerk face, but like to get what we're learning now is the thought process of physics. You got to write this down to do this problem because because this problem actually now is slightly tricky. Some people did not get this problem right. That's no shame on them. That just means there's something about this problem that's not 100% obvious. And some people did get this. Actually, honestly, this year, a lot of people got this right the first time, which is super impressive. 20 years ago, when I used to assign this problem at the stage of the year, almost no one would ever get it right at first. Like, seriously, I'm not shaming you. Like, it's meant to be a little bit thought provoking. A lot of you actually did get it right the first time, whereas 20 years ago, nobody would. I'm hoping that means that your generation is that we're just getting smarter, or I'm becoming a better teacher, or well, no, not that. We're getting smart, or maybe it's that 20 years ago, there weren't YouTube videos to check the problem. But if that just means that we're all much more resourceful now and industrious, great. A lot of you got it right. Let me say that but a lot of you didn't. The way to get this right is, first of all, to actually respect and obey the fact that we have to write down a step 3 GDP. And this is the only one that could be written down. Now, the reason, sorry, I'm getting all over the place. If you want to get this problem right, you got to write this down. I mean, if you literally want to get the right answer, you have to write this down. I think I mentioned yesterday, if you got the answer 50, it's not right. Like, the answer 50 is not right. If you got the answer 50, it's actually because you either didn't write this down, or like you didn't do a step 3 GDP, or you made up a step 3 GDP, either on paper or in your mind. Like, just to be clear, and again, I'm not saying this to shame, I'm trying to make a point. It seems like the answer to this problem, the problem is you go up at an average speed of 40, you come down the same hill at an average speed of 60. What's your average speed for the whole thing? Of course, when I first looked at that, I thought it was 50. I mean, that's not dumb and that's not outrageous. I would think it might be 50, but if I'm starting to break down my thought process into steps, I realize that the reason to think that it's 50 is because my brain somewhere is taking 40 and 60, adding them together and dividing by 2 and getting 50. And that procedure is correct. Like, yes, if you add 40 to 60 and divide by 2, you'll get 50. But that's what happens if you just skip straight to step 4. If you just start doing math work right away and just averaging numbers together because you see the word average and you get 50, you're probably doing step 4 quite correctly, fully correctly. But you skipped step 3 because you made up the idea. Not you, me, if I did that. If I just add 40 to 60 and divide by 2 and get 50, I'm just making up the idea that in order to get the average speed, I should average a couple of speeds that I see. That is not an idea. I mean, it is an idea, but it's not a right idea. It's not a GDP. It's not a true statement of physics. So this is not meant to be a trick question. It's not meant to be obnoxious, but it's meant to be like right away, like a wake up kind of thing. There is no GDP. There's no statement of physics we have right now that says average speed equals the average of the speeds. Now, I'm still going to pause. I'm going to go on in a second. But again, most people would do that, including me when I first saw this problem 30 years ago. I did that. Why did I do that? Why did I make up a lot? Like, when you hear it, it's sort of like, oh yeah, I guess we never did say that. I guess that's not true. So why would I even make up a truth? Why wouldn't I just go for the universally reliable truth that's written right here? I'll tell you why I wouldn't. Because just like you, if something seems a little bit hard or a little bit wonky or janky, I panic a little bit, whether I realize I'm panicking or not. I look at this problem and I go, whoa, this problem's a little hard because he never gave me the distance of the hill. If I were on an exam and I saw this problem for the first time and I'm going and I know my physics and everything, but I get this problem and then I'm like, wait, what? He goes up, it goes down. What's the average speed? Part of my brain might go like, okay, average speed, like he's told us a million times, average speed is distance over time. So then I look, okay, so what's the distance? But then my brain goes, wait, he didn't give him, I don't know the distance. So I panic a little bit. Well, no, if I'm me, actually, I panic a lot. Some of you might be calmer than I am. So my brain goes, whoa, you don't know a distance. You don't know a distance, dude. Don't go over there. Or you don't know a displacement. You don't know an X. So don't go over there. It's not going to do anything for you. You don't freaking have an X. So my brain goes, all right, do something else. Like, well, he wants an average speed. He's looking for average speeds. So like start averaging speeds. Okay, sounds good. And my brain starts doing that. This is very common for smart people, for successful people, for hardworking people. When we get to stressful exams or homeworks or whatever, the first thing we often do, if we're a little bit challenged, is we start scrambling for things that seem relevant. We write down things that seem relevant, and then we start trying to make them true. I don't know if you can relate to what I'm talking about, but often if I'm on an exam or something, I don't know what to do. I look for like, oh, okay, what does the professor want? Like, oh yeah, all right, this is one of those problems about average speed. So he's gonna want me to average, like he wants an average thing. So I'll start averaging like I've learned in my math classes. So I start like trying to think of what's relevant and desired, and then I just try to like make it true. That's what everybody does. And I'm not saying I consciously do that, but that's just a natural instinct. I'm here to say the discipline of physics, the thing that's tricky to get used to at first in physics is you actually want to literally invert that. What you want to start getting in the habit, what I want to start getting in the habit, when I'm calm, I want to start getting in the habit that will serve me for when I'm panicking. The habit I want to get into is instead of trying to write down things that are relevant and then make them true, I want to write down things that are true, even if I don't know how they're going to work, even if I don't know how they're going to be helpful, even if I don't see the light at the end of the tunnel. I want to write down something that is true and trust that if I write down something that's true, that then I can start making it relevant. Don't go from relevant to true, because you can't make something that's not true true. Go from true to relevant, because you can always make something that's true relevant. So I'm saying trust in the process. I write down average velocity equals displacement over time, even though there's a part of my brain that's going, don't do it because you don't know the displacements, yo. No, do it because it's true. And if nothing else, you'll just literally, if you're in my class, you'll literally get points for having written that down, even if you can't go any farther than that. But my suggestion is to you that if you start trusting that you write these things down, you will be able to go farther than that. So, all right, so enough. So I wrote that down. I'm looking in the chat. Okay. So I wrote that down. That's my step 3. There's nothing about averaging speeds here. There's just average velocity equals displacement over time. Or put another way, if you like, if back to the other person, I could write like average speed equals average of displacement over time, if you know what I mean. But okay. So now I'm going to start step 4. I'm going to start like doing math. Hold on, I'm just changing the view on the screen. Bear with me for a second. Why does that happen? Sorry, well, all right, I'll just leave. Wait. Sorry. Okay. Okay, so I wrote down, so average velocity equals displacement over time. Now, seems like there was a whole bunch of unknowns. First of all, number 1, x naught. Remember, x naught always means where, it doesn't always mean 0. It means initial position. Position when time equals 0. But you're going to see more and more, especially after the train of thought homework, that can be up to me. Like I can impose I'm going to look at this problem from a perspective that is convenient. Since no one ever told me, no one ever said anything about the size of the hill or put a number line to it or anything, I can just decide that the beginning of the hill, where the beginning of this experiment is what I'm going to call position 0. So I'm letting it equal 0. Let x naught equal 0. So I'm crossing out. So from here on in, my simple version of this equation is v bar equals x over t. So it's all about v bar equals x over t. But the annoying thing is that I don't know x for up and I don't know it for down, right? That is annoying. So I'm going to confront that directly. I'm going to say like yesterday. So this is all step 4, doing the work now. Like yesterday, say if v bar equals x over t, then I can rearrange, right? I mean, I could say, I could take that and rearrange twice and say that t equals x over V bar. That's again not a new, that may look like a third equation to some of you. But it's not a triple equal sign. I'm not saying now memorize 3 more equations. I'm just saying if V bar always equals X over T, then we can rearrange at will. I mean, you've done this before in a million science and math classes. So I'm saying now that if I want to get the time will be the displacement per the average velocity. So I can apply that to one segment at a time, just like we did in number line, right? If time for some segment, for some interval, for some experiment, if time equals displacement divided by average velocity, then the time up, which we don't know, will equal the displacement up, which we don't know, divided by the average velocity up, which we do know, right? So T up should equal X up over 40. Now, again, I don't know what X up is, but I'm just trying to encourage you that this is the whole power of algebra or math in general, is that I'm writing a bunch of things down, even though I don't know what I know what I'm writing down, but they're referring to quantities that I don't know. That's why they're called X or whatever. But that shouldn't stop me from writing them down. I'm doing work to get somewhere. Okay, you know this. I don't know why I'm really just trying to say, don't be afraid to start. Don't assume you have to see how to finish something in order to start it. And if you really follow this particular sequence of steps, you will find more and more that you literally could start these things having no idea, feeling like you have no idea whatsoever. And if you follow the steps, they will take you to an appropriate destination, even if you can't envision it initially. Anyway, I think you get that. So T up equals X up over 40. Similarly, on the next page, T down equals X down over 40, right? So what? Well, the big so what is that, I mean, that seems like a whole bunch of unknowns. I mean, T down, I don't know. T up, I don't know. X down, I don't know. X up, I don't know. But X up and X down are the same thing. So I might as well just call them both X, right? And that's what I'm saying, right? Like the distance up the hill is the same as the distance down the hill. So for the round trip, now we're finally getting somewhere. I could actually say, wait a second, even though it feels like I don't know anything anywhere, I really, really know a lot. And I really don't know very little. I could say the average velocity for the whole thing is the average velocity for the whole round trip, or the absolute value of the average velocity for the whole round trip is the whole displacement. Or maybe I should even do it like this. Sorry. Hold on. This is another, I'm just gonna make a technical point here. If what I'm about to do, you don't like, don't over worry about it. No, I'll leave it. I see them because we're already here. This is what I mean to say. Yeah. The absolute value of the up equals the absolute value of the down. In other words, even if one displacement is positive and the other is negative, the distances are the same. So I'm going to call them X, right? So, and this is bad handwriting. Let me just fix the handwriting. So I'm saying the average velocity for the whole thing is displacement of the whole, the average speed for the whole thing is distance for the whole thing divided by time for the whole thing. So the average speed for the whole thing is X plus X over T plus T, right? Well, the X's are the same, so I can combine them together. And I could say that the average speed for the whole thing is 2X divided by T up plus T down. Now I'm leaving it as T up and T down because they're different, right? The displacement up is not, the distance up is not the same as the distance down. The distance up is the same as the distance down. The times are not. So I'm leaving the up and down designation there, like they're different. But do I know, are they totally unknown? No, we just figured out a minute ago that I can express them in like I can sub in that T up equals X Something really wrong with the stylus. T up equals x over 40. We figured that out before, and T down equals x over 60. So what I have now is average speed equals 2x all over x over 40 plus x over 60. And that's looking pretty messy. That's looking complicated, but now it's just a question of like, but it's true. And now it's just a question of simplifying. And notice this. No, even before I go to the next step, as much as it looks like an ugly fraction, it is an ugly fraction. But there's only one unknown in it. The unknown seems to be everywhere, but the only thing that is not known in this ugly fraction is x. The only thing that's not known is the size of the hill. And now if you look where the x's are, so the next line with the reds, I could factor out an x from the top and factor out an x from the bottom. And then I'll have x over x. And in other words, however you want to put it, the x's cancel out, right? Like x divided by x is the same thing as 7 divided by 7 or 4 divided by 4. It's 1. So the x's cancel out. Before I go any further with this math, I mean, this line right here, I'm not done at this yellow line, but I'll tell you this, if I were in an exam or something like this right now, or if this was like, award-winning research, like cutting edge research or something, if I get to this line, I'm having a party in my mind. Because when I get to this, even if I hate fractions, as some of you might, or like, even though I don't know how to deal with adding 2 fractions in the denominator of a big fraction, like that all may look very messy, fine, but I don't care. I'm having a party in my mind because these x's are canceling out. That means I'm totally done with any hard physics. Now it's just a question of arithmetic computation. Like either I will be able to figure it out now because I'm calmer. I'll be able to deal with these numbers now because I'm calmer and I know the hard physics is over. Or for heaven's sakes, I'll get a calculator or a computer or a friend and they'll help me deal with the numbers. But when the x's dropped out, that meant the physics was over. This line means, oh my God, the thing that was the most stressful about this problem from the start, the fact that no one ever told me the distance of the hill, just became irrelevant. Because what I just learned in this line is the reason no one ever told me the distance of the hill is because it doesn't matter. Or put another way, if this question actually makes sense and no one did tell me a distance of the hill and yet they're expecting me to get an answer, that must mean, if the question is not a flawed question, it must mean that the final answer is independent of the size of the hill. That's pretty exciting. So I'm going to continue with the algebra now, or the computation, and then I'm going to go back and say more about that. But the x's drop out. I'm just looking in the chat. Okay, every time I look in the chat, I see beautiful diagram, and I'm like, wow. No, that is funny though. Although I'm still trying to figure out if it's funny or if it's, well, it is anyway. All right. Someone soon better put something else in the chat just to like de-traumatize me. But all right, so the x's cancel out. So now I have this thing that, again, some of you might be intimidated by, but please understand. And sorry, on a more concrete note, at this point, if you were on an exam for me and you got to this point, like people are at different levels of comfort with math and computation, all that stuff, but and math is inseparable from physics. I mean, math is huge in physics, but this is a physics class, not a math class. So the other thing is that if you get to this point in an exam problem or something like that, once you've gotten here and now it's about number manipulation, you've gotten a ton of the points. So even if you don't perfectly do the number manipulation now in the last couple of steps, if this were an exam problem right now, at most, if you messed up the numbers now, you'd lose 2 points. It's hardly a big deal in the grand scheme. And I'm saying that, number one, so don't stress over the 2, but also if you even know that going into the numbers, knowing that it's not now, your whole life doesn't depend on these numbers, actually for many of us will be calmer and be able to deal with the numbers better anyway. All you got to do with the numbers is you're going to add the 2 fractions in the denominator. So you want to find a common denominator, right? So the only way to add 1/40th and 1/60th is to turn them each into 1/20ths, like, right? So I'm in effect, I'm multiplying this by, sorry, by 3, sorry, by 3/3, and I'm multiplying this by 2/2, right? So I get 3/120 plus 2/120. So they have a common denominator now. So I can add them together. So I get 5/120 in the denominator of the big fraction. So I have 2/5/120. So how do you divide fractions? You multiply by their reciprocals, right? So I multiply 2 by 120/5. I get 240/5. Okay, that chat is driving me crazy. So I just added two. Okay. I'm gonna open a portal for myself. So I get 240. So that's my all my step 4 work. I probably lost everybody and we're bored already with all these comments. Oh, there's more. Oh, look at all the videos. I didn't notice that before. Thank you guys. That's awesome. Okay. That's like a big record for this state in the year. Thank you, Skylar. Thank you, Emanuela. Seriously. And thank you, Andre and Andre. Right, and obviously Gabriella. Okay, so now for my final answer circled, is 240/5, 240 miles over 5 hours is the absolute value of the average velocity. In other words, the average speed is 48 miles per hour for the round trip. That's my step 5 FAC. Now I'm going to pause. So first of all, let me pause for a second. There is something in the chat. Thank God. Right. Okay. Wait. All right. So someone in the chat, good question. Someone in the chat is asking, why are we using average velocity when we can do this question in average speed, which is the initial question. They're saying it wasn't the question about average speed, but I'm using average velocity. That is a really good question, but I will admit now, that's what I was trying to address that question a lot at the beginning of the class. Like, that is a really good question. I feel like a different person asked it on Monday. It is a really good question, but I feel like that's what I was spending almost maybe too much time at the beginning of this class trying to address. My condensed version is, yes, I agree. The question is about average speed. And that's why my final answer should be about average speed. And it is. But I feel like now we're at a realm where we have equations and symbols for average velocity. So, and more we're going to be thinking about average velocity because we can express it with equations and symbols. So I find the math largely easier to do if I think in terms of average velocity, or at least in terms of those symbols. So I was using those symbols to do the math, but I kept putting absolute values around them to remind myself that I was just meant speed. So I made the choice. You don't have to do this, in other words. I made the choice. I'm trying to use these early homeworks to transition us all more and more into equations and math looking stuff. So I expressed it in the mathematics and the equations of average velocity because I think that's easier or more instructive. In more and more, you're going to be hearing about velocity and you're going to be hearing about speed less and less in this class. So I'm trying to transition and I wrote it that way. But yes, I put all the absolute values around it to keep it as speed. And I expressed the final answer back as speed. If you did it a different way, but you still got the right answer, that's totally fine. But also, if that answer still doesn't really make sense to your question, maybe replay the beginning of the video because I think I actually over talked about that at the beginning, but it is a very good question. Okay. Oh, okay, great. Thank you for acknowledging. Okay, awesome. So now I want to say a number of things about this answer. Now, again, I think this is not an easy problem. I think those of you who, there's people at different levels of this problem, but I would hope that most of us would agree that it's slightly harder than the ones before it. Like hopefully it's not impossible or crazy, but it's getting a little bit harder now. Some of us did not get it right, totally fine. Some of us did get it right, but needed more help than usual or needed to think about it more than usual. Some of us might have gotten it right, but still don't quite know why it's right. Or put another way, I'm saying the answer to this is 48 miles per hour. That's the answer. And the way to get there, there's more than one. Your homework might not look exactly like mine, and certainly your homework might not look exactly like mine. But in order to get there, I'm telling you, you can't get to 48 without somehow following all the steps of the 5-step method. You might not call them that. You might still be getting used to them, but you've got at some point to recognize the importance of step 3 GDP, whatever you call it in your head. Like you've got to write down something about average velocity equal or average speed equaling distance over time in order to get this 48. And when you get this 48, you realize it's not 50. So let's pause for a second now. In English, like 50 is not the answer. 48 is the answer. The takeaway here in a way is average speed does not necessarily equal average of speeds. It equals distance over time. That knowing that is how you get this right answer. But if you are like the person in direct chat today or the person in direct chat Monday, if you are being careful and responsible and listening to all these things that I'm saying and seeing that I'm trying to tell you all that equations are meant to capture things that actually make sense in our mind, that equations are meant to just be symbolic expressions of thoughts in our native language that actually we agree with, then you might be thinking something like those of you who didn't get the right answer or people that did get the right answer, you might be thinking something like, well, this is all very nice math and equations, but really, give me a break, professor. Like you might be thinking like, wait, are you kidding me? Like the big point of today is that average speed is not the same meaning as average of speeds, but yet you're trying to tell me that the equations of physics like actually make sense and correspond to English. So what the what, yo, you might be thinking so, or you might even not know that you're thinking, but you might be irritated or bored or confused because you're like, professor, you said that these equations like are supposed to make sense, but now you're literally saying that the big point of this problem is that average speed is not the average of the speeds. Like I freaking average the speeds 40 and 60, I got 50. You're telling me the answer is 48. Like I can accept that if that's physics, but like, how are you saying, professor, that this physics actually makes sense if the average speed doesn't even seem like an average of the speeds? Good question. Good concern. I'm not trying to confuse you further. I'm trying to say if you're concerned about any, or even if unconsciously you're bumping on this problem because something like that is going on in your head, I'm here to say, no, you're right. We are here to try to make sense. We're here to make sense in a very precise way. So here's what I'm going to say now. There is a reason that we're using the word average. We're not just janking around. We're not trying to confuse you or just using black magic. The reason we call it average speed is it is average speed. What does average mean in the first place? An average value in the first place by triple equal sign, an average value is the one value that we use that best, most accurately represents a whole set of varying values. That's what an average is. That's the triple equal sign. What's the double equal sign of average? Like how we get it, how we compute average. There's many different ways to compute averages for many different circumstances. But what average always means is the one value that represents a whole bunch of changing values. So if you say that your average exam score in a class is 85, what you're saying is that even though you got a bunch of different scores on different exams, in the end of the day, the kind of student you are, your performance is exactly equivalent at the end of the day, or it's most closely equivalent to the kind of student who got an 85 on every single exam. If you had to pick one number to represent, like, even though sometimes you were getting 80s and sometimes you were getting 90s, if you had to pick one number that captures the whole trend, it would be the number 85. That's what you mean when you say that your average is 85. Now, the fact is, you could add up a bunch of numbers and divide to get the 85. But what I'm going to pause right now and ask you, especially maybe someone who, like, yeah, I'm going to ask you if that's what average means. If average means the best number to represent the whole, and if you have if you're thinking in terms of exams, like, why in this case, why could I claim that 48 is an average Why can I claim that 48 really is the average speed here, even though if you add 40 to 60, you don't get 48? Like how can you compare this hill to test scores, to exam scores? Why is it that it doesn't work to add 40 to 60 and divide by 2 to get this answer? I'm asking you. I'm going to pause for a second. You can put in the direct chat. In fact, I'm literally going to pause. We're going to start opening a portal for this too. I'll repeat the question in a minute, but I'm asking you all for participation now. I'm going to repeat the question, and I want everybody to put something in the direct chat, even if it's something like, I hear the question, but I don't know the answer. Or maybe at best, you want to show me, like you might even say, your question is this, but I don't know the answer. Okay. Like just show me that you're paying attention, in other words. And if you do have an answer, put in the direct chat or raise your hand or whatever. Here's the question again. How come, how come the how come it doesn't work in this case to add 50? How can I call 48 a reasonable average if 48 is not 40 plus 60? How can you relate this problem to like exam scores? Like, why isn't it fair for me to say, like, you got a 40 on an exam, you got a 60 on an exam, so your average is 50? How am I saying that you got 40s on exams and 60s on exams, but you ended up getting a 48? What about this problem is producing an average that doesn't, that is more complicated than just adding the two numbers together and divided by 2? So just put something, if you even vaguely understand what my question is, just put in the chat, I understand what your question is. But or if you have an answer, put it in the chat. And it can be the private chat or whatever. In fact, I'm going to walk away for a second. But I'll say the question again. I'm really looking. Could someone try to explain this hill problem as though the 40s and the 60s were exam scores? Could someone, and again, if you can't, just put in the chat. I get what you're asking, but I can't do it. But I want someone to explain how, like, if 40 represented some kind of exam scores and 60 represented some kind of exam scores, how are we getting 48? Okay, I see one person. Oh, I see people in the direct chat now. Okay, okay. I'm looking. This now things are happening. Good, good, good. And anything you put in the chat, you could submit for points. Obviously, you vaguely understand the question. Okay. Oh, good. I'm seeing a lot. Oh, awesome. This is good. There's a lot in the chat. This is good. I'm just reading. Oh, and some people are going public, which is great. Like Andre, great. That I totally appreciate that you're going public, and that's good. And I see that you're also reading. Wait, how are you reading the responses if they're? Oh, I see. Oh, I see. I see. Okay. Oh, awesome. All right, hold on one second. This is great. I'm going to walk away for one second just because I have to. Oh, one second. I'm going to. Okay. Oh, interesting. Okay. Very good answers here. Okay. There's one direct chat thing that is like a personal thing. Let me just respond to directly and then but these are great. And you should definitely submit these for points. Hold on. Okay. Okay. These are great answers. I'm tempted to read a lot of them out loud, actually. Okay, but I'm watching the clock. No, and I really appreciate it. These are you're a very good class. Like seriously, like there are some answers in here in the chat where it says like I understand the question, but I'm not sure how to answer it. And I actually believe that because there's enough of these answers that are like the ideal is that you actually like sort of mirror the question back to me and then say I still can answer it. But there's enough of that going on and enough of very different clever answers that what I'm definitely seeing here. Sorry, I'm running out of what I definitely see here is this is worth talking about because your answers are, I think you do largely see my question, but your answers. So I'm going to cut to the chase. What's going on here is that this is like exam scores. It is. You can think of this like exam scores and averaging. We are talking about averaging in the sense, in the logical sense. But the deal here is, as a couple of people did put in the direct chat, the deal here is average velocity, average speed is distance per time. Per time, time is the independent variable. Like time is what's analogous to test scores here. Time in this case is like exams in the classroom. So the catch here is it's totally as though you got 40 on some exams and it's totally as though you got 60 on exams, but but you got 40 on more exams than you got 60 on. The key thing here is the car went up a certain distance and then went down that certain distance at a higher speed. So the car definitely spent less time going up than it did going down. And a number of people said this in the direct chat, but not everybody, but a number of people. And you know who you are. And by the way, if you are one of those people, like I definitely encourage, like screenshot and like remind me tonight, like I was one of those people that nailed it, whatever. The car took less time to do 60 miles an hour than it took to do 40 miles an hour. So it's really totally still is a concept of averaging and all of that. But the situation here is, what if you got a bunch of 40s and or if you got a bunch of 60s and then a bunch more 40s? And we had to add them all together and divide by the total number. So then what answer would we be? Now, I'm going to be more specific in a second, but because there's more time spent going 40 miles an hour, that's why our answer is closer to 40 miles an hour than it is to 60. Like it's a little bit under 50. It actually is super logical that our average speed is a little bit slower than 50 because we spent more time going the slower speed. The only catch left, so hopefully that sort of makes sense so far. I'm saying it is like test scores. We are talking about averaging here. What we're strictly talking about here is a weighted average. And yeah, we're strictly talking about a weighted average. So the only real question one might ask is, okay, I sort of get it. Like it's more test scores of 40 and fewer of 60, but like how many more? Like how would we know? Well, that's what this math is right here. The minute the X is dropped out, the reason you're seeing a 3 and a 2 and adding together get a 5, like the 3 over 120 plus 2 over 120 is 5. That's the key right there. That is so key that no matter how your homework looked, no matter even if you did it what you think is a totally different way from me, if you got this thing right, I guarantee you somewhere in your homework, in this problem, you have a 3 and a 2 adding together and making a 5 somewhere. Why 3 and 2? Because 60 miles an hour is 3/2 as fast as 40 miles an hour. With the 3 over 120 and the 2 over 120 is what that's saying right there. It all looks like gobbledygook, but it's saying you're going 150 times as fast when you come down. You're going 3/2 as fast when you come down. So conversely, inversely, you're going 2/3 as fast when you go up, right? Like 3/2 flipped is 2/3. You have to necessarily take 2/3 as much time to go down the hill as you take to go up the hill. So whatever the length of the hill is, the amount of time on the way up is like 3 over that given length. And the amount of time on the way down is 2 over that given length. 3 plus 2 is 5, i.e., in the end of the day, at the end of the day, you're going, at the end of the day, and at the end of the day, it's literally equivalent to taking 5 exams where you got 40 on 3 of the exams and you got 60 on 2 of the exams. That's literally what this is. Now, I'm not saying you should have done it that, like, I'm not saying you could have or should have thought, oh, if I make this like exams, I could come up with it's 3 and 2. But I'm saying that's what the math is actually capturing, that it is an average. It is an average, but you don't just want to average 40 and 60. You can't do that. That's unfair. That's actually, so I'm trying to say in the long run, we're not using words to throw you off and trick you. This is not meant to trick you at all. It's meant to reveal that there's something tricky going on when we move from English to physics or from math to physics. It's tricky. We have to be careful, but we're not trying to trick ourselves. We're trying to say, oh, yes, this is an average, but let's remember how deep the concept of average goes. We can't just average a 40 and a 60 and say it's a 50 because it's not. That's not what's happening. What's happening in effect is we took 3 40s and 2 60s and averaged them together. So 1, 2 less. Oh, and I see there's other things in the chat, so I'll get to the chat in a second. So really what I'm saying is, one other way you could have done this problem and it would be totally acceptable, the minute you see those X's cancel out, or the minute you realize it doesn't matter what the size of the hill is, if it doesn't matter what size of the hill is, actually, you could literally just make up any size of the hill you want. You could make up the size of the hill and then just plug in. You could be like, oh, the average velocity of the average speed of the whole thing has to be distance of the whole thing divided by time of the whole thing. And you can make up a size of the hill like you could pretend that the size of the hill is 120 miles. Or you could say it's 240 miles because it's so easy to deal with. You could say, fine, up it's 240, down it's 240. So on the way up, we're going 60 miles an hour divided, 40 miles an hour divided by 240. Sorry, we're going 240 miles an hour. Sorry, we're going 240 miles divided by 60 miles an hour. That's, I'm getting myself all tongue-tied. Yeah. We're going up 240 miles divided by 60 miles an hour. So we can say that's 4. And then on the way down, it's 240 miles divided by 60 miles an hour. So, I'm sorry. So that one was 6. And the way down is 4. So 6 plus 4 is 10. We can say, oh, we go 240 up, 240 down. That's a total of 480. And 480 divided by 10 is 48. What did I just do? I probably lost everybody when I just did that because I almost lost myself. I'm just saying, even if we made up a size of the hill and made up that the hill was 240 miles, these calculations would look slightly different, but in the end of the day, they would have the 3 and the 2 in them. Everything else would cancel, and we would get 48. So we could have just made up a size of the hill. The bottom line is it's like 3 test scores where you got 40, 2 test scores where you got 60. So it's 48, which is slower than 50. And the bigger bottom line that I'm really trying to say is average speed equals distance over time. Don't just average speeds together to get average speed, use distance over time, but don't think that that's because we're using language in a new or counterintuitive way. All this stuff in the end, as it unfolds, all should go back to thoughts that actually do make sense. And English or Chinese or Spanish or Hebrew or whatever that actually does make sense. We're not trying to invent new logic. We're trying to apply logic very strictly to the world of space and time. Okay, sorry, that's a big rant. I'm looking at the chat. I see something in the chat. Hang on a second. Okay. Right. Sorry. Okay. Now we only have 4 minutes left. So that's the big problem. The next problem, I will quickly, oh, sorry. The next problem, I'm just going to say very quickly. Now, again, please, I think everybody's understanding. You could still revise and upload. If you're learning more from this class, if you see something you did wrong before, you can revise and upload, blah, blah, blah. And sometimes I do a full step method like I did there in class. Sometimes I don't have time and I don't. So on this next one, Grandma Grimm, I'll just be very quick about this. I will tell you that on this one, same logic, same issue, that you can't just average 80 and I don't even remember what you can't just add, 40 and 80. You can't just say 40 plus 120 divided by 2 is 80. So my answer is 120 because there's a time factor here that's different. Again, you have to just respect your one and only step 3 GDP, that average speed equals distance over time. If you look at this problem the same way as the last one, you can get an answer. The one thing that's trickier about this problem is you'll see at the end of the day that the answer you get for this one is perhaps a little bit irritating or thought-provoking. That if this question is, she goes out the 80-kilometer trip at an average speed of 40 kilometers per day, and then she comes back the 80-kilometer trip at some speed we don't know, but we need to figure out what that speed is to make an average to be 80 kilometers per day for the whole thing. Well, the bottom line answer is she would have to go at infinite speeds. She cannot physically accomplish a task. That's the answer. The answer is not that the question is wrong. The answer is not the physics cannot be solved, but the answer is if we solve the physics, she would have to come back at infinite speed in order to accomplish the task, like way faster than 120 or 160. Why? I know we have like 1.5 minutes left. Why? Bottom line is, if the entire trip, round trip, is going to be at an average speed of 80 kilometers per day, that means the entire distance divided by the entire time has to be 80 kilometers per day. Well, the entire distance is 160 kilometers. So she's got 2 days to do the whole thing. Like if she's going to accomplish a task, she's got to do the entire round trip in 2 days. I'm going to say that again, 160 kilometers round trip, like 80 out, 80 back, 160 round trip for the whole thing. Go an average speed of 80 kilometers per day. So distance divided by speed is time, we've established. So 160 divided by 80 is 2. So she's got 2 days to do the whole thing. However, when she goes out, it's 80 kilometers and she goes at an average speed of 40 kilometers per day. So she takes 2 days to go out. So she is only allowed 2 days for the whole thing in order to accomplish the task, but she takes 2 days to go out. So she's used up all of her time. It doesn't mean the math blows up or anything, but it means, in order to get back and accomplish a task, she's got to get back in 0 time. She would have to go infinite speeds. I'm not saying particles can do that. I'm not saying that's some new physics or Back to the Future or something. I'm just saying that's what she would have to do to answer this question, to accomplish this task. So the answer is infinite speed. She can't do it. That's it. Okay, so that's class. Thank you for being so patient. And I will hang out for a minute and answer any questions. But other than that, there's no new homework other than catch up or do train of thought homework 3 if you haven't done it yet. But everybody's still on time. Everybody's okay. Whatever. But just catch up and revise and re-upload for next Monday. But I'm stopping the recording. I'm still here. Have a great day. Goodbye. Goodbye. Goodbye.